Welcome to Engineer's Box. Now today, I'll show you what programming languages consist of and why we use them. And also with that, you'll be able to understand almost any programming language that's been created and how the code interacts. Also, I'll go over what commands are in Minecraft and how they work. So, let's jump into it. Now, first of all, I want to give you a little bit of a understanding of coding in a programming language and what it is. So to understand what coding languages are, you first need to understand why we use them. The main idea behind them is that the programmer is having to do something over and over again that is repetitive and really irritating. They'll probably realize, hey, I could streamline this by making something that does these repetitions with ease. Today, these languages are making writing functions that are more common to code easier by simplifying the sub-process into a common single process with a sophisticated package. Something like Java or Python, things that can do iterations and loops and things like that, are a really great example of this. The first iteration usually ends up with something like an assembly language, which is a step above machine code being ones and zeros and binary, hexadecimal, and that sort of thing. Another big reason is error passing. With machine code, there is no function for active error passing, so detecting where there's an error in the code and being able to deal with that. And thus one wrong entry can cause a multitude of problems. And then from there we can compile this language into a higher level one that is somewhat comparable to the English languages. For the English language, I should say. For example, C++. This one is quite an easily read one. You can read through it and understand what's going on, and it makes it easier just in general to be able to understand it rather than having to look through assembly and machine code and really struggling to get a grip on what's happening. So in this example here, we can see that the difference between C++ and assembly languages. Now keep in mind that these are the exact same programs, they're just displayed in different formats. So as we can see, with the C++, you can see up the top we've got a bunch of integers with different arguments and things like that. And then we've got an if loop, an if-else loop, and a return function at the end. So in this case, an if statement here, we're taking an argument 2 in this case, and we're making sure that it's not equal to 0. And then, so if it isn't equal to 0, then it goes down to that second line and just basically passes through that. And then if it else, so anything that isn't equal to 0, well, if it is equal to 0, then it will pass through to the argument 1. And then after that, it'll just return another function after it. So as you can see, you could read through that and kind of understand what's going on. But if we read through the assembly code over here, which got a whole raft of different functions like pushing, moving, and dealing with just general pieces of coding, shifting them around to perform these functions, you would not have any idea of what's going on. So this is one of the key reasons why we do this. Now, one of the other really interesting parts of this is meta-languages. Now, meta-languages are used to describe the syntax of a programming language. There are 3 control structures that are required to describe this syntax. They are sequence, selection, and iteration. For example, in many languages, an identifier must start with a letter and then followed by like an optional sequence of letters and digits or any combination or order, or maybe even other things. But a selection is the second and further on characters that are either a letter or a digit, and then repetition is just multiple characters that follow the first letter. Sequences are a letter that's followed by other characters. So you can see they're pretty self-explanatory, but they're really key for these languages and the fact that they can run and deal with these large processes really quickly. Now, one of the most common the widely used structures of meta-languages is eBNF and its predecessor BNF. Now, BNF stands for Bacchus Noir form and eBNF stands for Extended Bacchus Noir form. There is another one, it's called Augmented Bacchus Noir form, but I'm not going to go over that as it's not really practical for what we're talking about today. So, BNF and eBNF. BNF Bacchus Noir form is a mathematical way of describing a coding language and was developed by John Bacchus and Peter Noir. Its primary goal was just to describe the syntax of Algol 60, which is a programming language developed quite a while ago with basically some of the first iterations of usable computers. So with the example of Algol 60, we can see here that it's quite a bit different, even though you can still read through it and understand it. So in this case, we've got a begin at the start of it, and then a comment, which has, because, well, as you can tell, it's not really written in English, the comment, but as you can see, there's a comment there, and that function just lets you write something to explain what's going on next. And then we've got an integer, which is equal to 20, and then it's just basically a bunch of processing commands that go through, and you can see that we've got we've got a for loop there. We've got some print statements so that you can print things to the console or a text box or whatever you happen to have there. And you can see we've got a couple of operations like adding and ending, and then returning things. So yeah, you can see that the BNF is quite good at concatenating a lot of these big loops and problems, because if we didn't have all of these loops and things like that, this program probably would be 1.5 miles long and it would take forever to deal with. Now the basic principle behind this is that you start with a symbol called the start symbol, and is represented by, okay, so why don't we take a look at S in this case. So the start symbol is represented by S, and then you replace that with a set of given rules. Now, BNF grammar is quite interesting in that it states that things can only be the product of what came before them. So in this case, S can only become F and N, as we see here, and then F and N can only become either FN or DL dot DL, so the dot being a period, so you can actually create things like decimals, things like that, floating points. So that's pretty good. Basically, this is all it does is it's just stating that the symbol on the left-hand side of that little equals sign with the colon and equals must be replaced by only one of the options on the right. Now, these operations are separated by this little split line here, and the alternatives usually consist of both symbols and terminals. Now, terminals are simply pieces of the final string, the things you're finally going to output, that are not symbols. So they're called terminals because they have no rules for them. They just terminate the process, pretty much. So in this example, we can see that the replacement steps here go through, and you can eventually substitute in numbers to get whether it be a whole integer, a floating point, or whatever other combination you like. So that's pretty cool. So if we have a look at this is an example of that replacement process. So we could start with the symbol of S, and then as we remember, the replacement for that can either be Fn or it goes to Fn. So we replace that with Fn, and then Fn becomes DL, or Fn again, or DL.dl. In this case, we're going to replace it with DL.dl. And then from that, DL at the start replaces with D. Now, D we can replace with a number, 0 through to 9. So in this case, we'll replace it with 3. And then DL on the right, we can replace that with DL. Then we replace the D with integers, and we go on so forth, on and on and on, until at the end we end up with 3.14, which is a bit of the string of pi, which is pretty cool. So, eBNF. Now, in order for us to replace a DL in that previous example, we had to use recursion, which basically means repeating a process over and over to express multiple of those Ds, or numbers in this case. This means that BNF is actually quite a lot more difficult to read and use, whereas eBNF, which is extended Backus-Naur notation, it solves this problem by adding 3 new operators. So a question mark, which means the symbol or the group of symbols in the brackets to the left of the operator are optional or can be continued on, so you don't have to continually go through each time and replace and then replace every time you want to add something. You can just add as many as you want straight away. An asterisk, which means that something can be repeated any number of times or possibly even just skipped altogether. Also an addition symbol, which means that something can appear more than one times or just one time. And this makes it so much easier, so we don't have to go through that really annoying process of having to replace each time we want to add something new. So with this, we can write eBNF grammar like this, which happens to be a hell of a lot smaller, as you can see. So the S becomes, instead of going through the FN process, you can have it straight away, so you have a bunch of options. So in this case, we've got S, which can be replaced by an optional negative, as we saw before, and then we see this question mark, which means that the symbols to the left of it are optional. So remember that. So the negative is to the left of that, so that means it's optional. And then obviously to the right of that, we have a D with a plus to it. And remember, a plus means that something can appear one or more times. And remember, a D was anything like an integer or a letter or something like that. So in this case, D, we can have as many as we want. And then as soon as we're done with that, we can go to the brackets, which are on the right of that. And then we have a decimal point. So if we want to create a floating point number or a decimal, then we can add that in. And then after that, we can add the rest of our digits in. So D and then a plus. Remember, the plus means that it can be added one or more times, whatever you'd like. And at the end of that bracketed form, we've got the question mark, which means that it can be either optional or not optional, depending on whether you want to use it or not. So yeah, so that we can see that it's a hell of a lot more simple now, and it's so much easier to read and use, which is much, much easier now. So we can see that EBNF is pretty much the syntax of all modern programming languages, such as JavaScript, Python, C++, C#, HTML, CSS, you name it, they've pretty much used this form. But the great thing about this is we can represent the syntax of it really easily, so we can just understand it without having to have a complex set of instructions and rules that we then have to apply based off situations. This one just, it takes into account all situations, so we can have any argument or whatever, and it'll suit it. So let's create a little programming language now. So let's say, for argument's sake, we want to call it Jolt with the file extension of jotdate.jlt. So we want Jolt to operate only on integers and a specific set of upper and lowercase letters with operators, so addition, subtraction, multiplication, division. And we want to create a diagram of all of these so that we can understand what's going on. So one thing we can do is use what's called railroad diagrams, which are actually these right here. So as you can see, we've got a whole bunch of different programs and statements, assignments, conditions, and all of these things here. Now they might look a bit kind of like, whoa, what the hell, what's going on here? But they're actually pretty simple. So if we take a look at the program, we can see we've got start, which is compulsory, as you can see. Anything that's in a rounded shape is a must, it has to happen. So start and stop are a must. And the statement in the middle, we can put a statement in there. And you notice that loop above it has an exclamation mark. Now what that means is that basically you can loop through it as many times as you want. You can add as many as you want, or you can just loop through it and then stop it whenever you want. So as you can see, we've already got the basis of a program. So let's take a look at a statement. What we've got here is the possibility of adding an input, an output, an assignment, a when, a pretest, or a post-test. So an input is obviously something that you input, whether it be from the code itself or manual input. Output is obviously the result of it. An assignment, if we have a look down the bottom, or the second underneath the statement, is actually its own little process. A when statement is pretty much saying that when something equals this, do this. It's very similar to an if-else statement, but it's a lot more simple, and you can add recursion to it. It means you can do it over and over and over again. So as you can see, we're actually getting kind of close to command blocks in Minecraft with the whole being able to chain commands, being able to create loops, things like that. And then also we got the pretest, which is basically you're testing something before an event, and then you have post-test, which is you're testing something after an event. So you can compare results and things like that if you really wanted to. So if we take a look at the assignment, we can see that we've got set, which is compulsory, and then an identifier. Now an identifier we can see in the bottom right corner there. Now that's an interesting one. So in this case of Jolt, we have to start an identifier with an uppercase letter. Anything from A to J. As we can see in the uppercase section up here, with the U case, it says A, B, C, D, E, F, G, H, I, J, K. H, I, J, sorry. Any of those are possible, but anything beyond J, it does not recognize. So, I mean, your programming language may not recognize the rest of these. It can, most do, but for argument's sake, we're not going to go with that. And then, so once you have your chosen letter, so say we do C, because why not? And then after that, we've got a little bit of a loop here where we can either put in a lowercase or a digit, or we can put nothing. So say we want to put in a digit, so we can go 0 to 9. Keep in mind that 0 to 9 means that it won't recognize 11 differently to 1, 1, which means that basically if it could recognize 11, it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 11. But because they're all separated digits, it means it'll only recognize them as single digits. So in this case, why don't we add 7? So we've got C, 7, and then I guess we could loop that again and add a lowercase. We've only got the options of A, B, C, and D, so let's add B. So now we've got capital C, 7, and lowercase b. So now we've created an identifier, so we can stick that in the assignment over here. And then, so we're setting that. So we've created a variable, what's known as a variable. Now, in Minecraft, these are pretty similar to scoreboards, so a dummy objective, where you can set it to a value or set it to something else. Basically, in this case, the assignment is, so we're setting that, so capital C, 7, lowercase b, and we can set it either to a constant, an identifier, or an operator. So say we want to create a little mathematical string here. So let's just add two numbers together. So a constant, as we can see over here, is defined by having, you could either have no negative or negative. So why don't we add, we'll take no negative and a digit of 4. So we have 4. So now we have a constant of 4. And now let's do another loop, and then we do an operator. So in the operator, we can see that we've got addition, subtraction, multiplication, and division. So we can add in this case, so 4 plus, and now we do another loop and create another constant, say 8 in this case. So now, actually no, we'll do 2 for the moment. And I'll leave that up to you why I won't be able to do 8, 4 and 8. Tell me in the comments why do you think I can't do that with this language. Anyway, so 2 and 4, we add those together, and then we can take a result. So if we take that assignment, remember the statement? We can stick that in there and then inside the program. So starting it and then the statement will say, okay, we've got an assignment. So it'll set it to the result of 2 plus 4, which is 6. And then it'll stop it. And we could even add another statement after that that says output. So then it'll give us the output, which will be 6. So then if we wanted to, we could even go further and say, why don't we do a condition? So a condition is where you can compare things using what's called Boolean statements. So equals to, less than, greater than, equal to or less than or greater than, or not equal to. Now in this case, not equal to is represented by a greater than and a less than signal together, but you can also be represented most commonly by an exclamation mark, equals. You'll find that in JavaScript and Python and most of the main programming languages. So as we can see there, we can do that, and we can do a similar sort of thing. So we can add another identifier, a constant, and we can also do and or if we wanted to. Those are two different operands. Now, an OR statement. Now, if you have any experience with Redstone in Minecraft, you know that we can create circuits. There is several different ones. OR, XNOR, AND, NAND, XOR. There's a whole bunch of different ones. Now, in this case, AND and OR. So it'll only give an output of true. If we use AND to compare two identifiers, it'll only give an output of true if both of them are true. Hence, this one and this one are true, therefore the statement is true. Or you can use the OR statement. This one or this one are true. So if one of them are true, then it'll give a true statement. So as you can see, with this very simple little piece of just basic programming language, you can have so much functionality, and we've done it with very, very minimal amounts of work. So this is great. And you can see that it's become quite easy to do things now. Now we don't have to write long long-winded statements that go on and on and on. You can do it with really simple loops. Now, this is the great thing about it. So now, if we take a look at commands in Minecraft, now the interesting thing about this is they are just by themselves a small set of built-in functions. Now, they could be all sorts of things. You've got /TP, you've got give, summon, all sorts of ones, and the list goes on and on and on. You can do scoreboards. There's so many different ones. Now, all of these are incredibly useful. Now, as you know, you can tell here that these already have their own syntax of brackets and greater than and less than symbols. Also, curly brackets as well, which is what data tags are held in. The square brackets mean that it is not required, although preferred, and the greater than and less than are required. And also the curly brackets are only if you're dealing with data tags. So commands just by themselves, they're a small set of functions. And these are the commands which, with a set of arguments that may or may not be optional or overloaded. So in this case, the second argument for /TP would be, you see the target player here? Target player basically means that you can either use it or not. So the destination player, however, would have to be definitely have to be entered. So you could just do /TP maybe to someone named Steve, and that would work. Or you can do /TP engineer's box Steve, so then it would take the player engineer's box to Steve. Or, as you can see, there's this other set of statements you can use, which is a TP and then a target player to a set of coordinates. Now, you don't actually have to use these coordinates, but you can if you want. So, I mean the target player, so you don't have to specify a player if you want to just TP yourself, or if you want to TP someone else, then you use that identifier. So, depending on what the function is, so in this we can establish that without an execution environment, so in this case a command block or something like that, or function scripts, a program is only really a single call. In this case, that means that it only runs once, and to repeat it again, you'd have to put it in a function script or a command block, something like that, or a set of command blocks. Now, the great thing about command blocks, especially with 1.9 and above, is that they've added some really interesting functionality to the system. Now, the impulse and the chain command blocks represent several functions that are executed in a row, much like over here. Now, you can interchange these with them different mixes of impulses and chains and things like that, but they all have the different functionalities. So basically, how much the conditional, so if we have a look inside of these, you can see that we've got a conditional set here. So we can either go from conditional, as you can see that changed the texture, the tile texture on the top, or unconditional. Now basically, conditional or unconditional means whether it will cause the next set of commands, the ones in front of it, to be executed based off what happened just before it, or alternatively to skip what was happening just before it, to skip the result. So that's pretty nice and easy to use, and we can see that we've got that conditional statement now. Now also with the repeating command blocks, we've got this conditional statement as well, but also these just create a constantly repeating set. So now, the great thing about these is if we have a look at this example, we can see that this is an example of a while and a for loop. Now you can find these in loads of programming languages. Python is the most common and the most well known, as well as JavaScript. So as you can see here, we've got two variables, sum and I. In this case, the while loop, when I is less than the value of 10, it will do what's below it. So it'll set the value of sum to whatever sum was and then add I, and then it'll print the value of sum, and then I will have 1 added to it. And also the for loop at the bottom, so for the value of I within the range of 10, so it'll do it 10 times, it'll add 1, it will add the value of I to sum and then print sum. So we can see we've got these two little loops here, and you can apply a very similar thing to these command blocks here. Now, you can see the conditionals and the non-conditionals here. So we've got this would be an example of an array of command blocks. So you've got a repeating with a conditional or a non-conditional. That's the impulse ones, or these are the chain ones. As you can see, they're all interchangeable. Now, something interesting about command blocks is that they have their own memory system. And this actually comes in three parts: blocks, Java runtime, and entities. Now, blocks have all sorts of block IDs, their states, their entity tile data, and so on and so forth. And they've also got three-dimensional coordinates where they're placed. Now, Java runtime is basically just what the game itself can remember, so values and things like that, and positions and absolute things that are constantly running within the game. Then you've got entities, which have their own set of tags like direction, equipment, custom names, attributes, size, all of those sort of things. And all of these can be altered by the runtime environment, but also almost entirely by our control. Now, the great thing about this is we've got pretty much 100% customizability, so we have control over variables and comparatives and all sorts of things like that. So as you can see, Minecraft's command language is actually quite sophisticated and is really quite close to how JavaScript and Python, C++ and things like that run. So as you can see, what we've gone over today, you don't realize it, but there's actually a hell of a lot of things happening. Even with our basic programming language that we created, Jolt, we can see the similarities to this in Minecraft. We can see how it runs. And in fact, Jolt is almost identical, the way those things run, to what's happening in Minecraft. So as you can see, Minecraft's actually a little bit of a hybrid, but it's nonetheless pretty advanced with a coding language. So I hope you enjoyed this today and learnt something from it. And as always, I'll catch you guys in the nearest of futures. Now, just before I go, I'll put in the description a link to the few sources and things that I used, as credit should be given where credit is due. So, as always, I'll catch you guys in the nearest of futures.